All right. So now we're going to go through a series of examples illustrating power analysis and effect size from some published studies in the anesthesia literature. Um, the first two are going to be actually from studies I was involved with the Navy Nurse Corps anesthesia program a number of years ago. And all three of the studies that we're going to be talking about for remainder of this lecture are included on Blackboard for your reference, and I would encourage you to read over them, skim them, paying particular attention to the methods section and discussion of the results in the context of the sample size. So the first one is a study that we did was looking at the effect of an epidural normal saline bolus prior to catheter removal on parturient sensory and motor function recovery. And this was considered a pilot study. And so the purpose of this study was to determine if injecting a 30 milliliter saline bolus to the epidural catheter after epidural delivery would hasten return of sensory and motor function in parturients who received a dilute local anesthetic solution with bupivacaine and fentanyl. And the hypothesis of this study was that the degree of motor block would be significantly less in parturients who received a saline bolus compared to those in the control group. And over on this side, I've highlighted some of the what they used in terms of methodology. Extended motor block, they're looking at differences in motor block was with the Bromage scale. You can see that here. And then what they did is we recorded motor block and sensory block were measured at baseline and every 15 minutes for the first hour following discontinuation of the epidural infusion. So this was a randomized controlled trial. It had two groups, a saline bolus and a control group. What do you think the independent variable was? Was whether or not they got the 30 milliliter normal saline bolus to the epidural catheter after delivery. What are the dependent variables? What are their outcomes they're measuring? Or I'm sorry, I was part of this. Degree of motor block, which was measured with a Bromage scale every 15 minutes for up to 60 minutes. We also measured sensory dermatome levels. And what were the level of measurement of these dependent variables? Well, it was ordinal. What do you think the appropriate statistical analysis would be? We're looking at differences between two groups. They're independent. And we're looking at ordinal level data. So if you chose the Mann-Whitney U test, you're correct. So how did we go about calculating the effect size? Or I should say, how did my students come up with this with our mentorship? And so what they did is, and you can go into the methods section in discussion of the sample size calculations. And what they said was, what we said was, there was really no studies that had ever done this before. Most of the studies the students had found were looking at surgical patients using much stronger, higher concentrations, like 0.5% bupivacaine. So, and most of the studies evaluated mean difference in time to full motor recovery. However, in this initial study, the students weren't able to follow the patients all the way out. So we just chose to follow them for the first hour afterwards and look at differences in degree of motor blockade. So they found this one study that was, because they used bupivacaine, and used that to base the differences on. In this particular study, they used 0.75%, very highly concentrated solution of bupivacaine. And they found a difference of almost 100 minutes. Pretty large standard deviation, so a lot of variability. And then what we said is accounting for the decreased local anesthetic solution used in this study, they estimated that a similar trend would be seen. And so we hypothesized that there would be a 50% longer duration in the control group compared to the saline group, of roughly 30 minutes versus 15 minutes. You can see the standard deviation of 21 minutes, standard deviation of 9. Our alpha error was at 0.05, or beta error was at 0.2 or 20%. And so based on our sample size calculation, we determined that 25 would be needed in each group to achieve statistical significance, meaning a p less than 0.05. We added in a 20% attrition, and we came up with a sample size of 30 per group. How large of an effect size do you think that was? You can go back and pause the video. You can look at the slides and go back to that size. Was it small, medium, or large? Well, it was actually a large effect size. Do you think they used a one-tailed or a two-tailed t-test hypothesis? Well, they didn't really specify, but if we go through some examples with some statistical, some sample size software, we can look at that. But if they did use a one-tailed t-test for their power analysis, what would that do to their sample size? Would it increase it or decrease it? What would decrease the sample size they would need? All right. I'm using this free software called G-Power. And this is referenced in the syllabus, and I also talked about it in the overview this week. It's free software that you can download that you guys can play around with, and I refer to it frequently because it has the ability to do a priori, and also has the ability to do post hoc power analysis. So you can actually take the effect size, use the data from studies, and you can calculate the effect sizes. So in this particular study, I entered in, I have a one-tailed t-test and a two-tailed, one-tailed and a two-tailed using a Mann-Whitney U test. Okay, and you can see the difference here with a one-tailed. You can see our critical value is what we would need is if we have a t-test is what it's using essentially in this one of 1.69 or greater, then we're in that level of significance. However, if we do a two-tailed, it's at the critical t-value is at 2. So we end up needing a larger sample size with a two-tailed hypothesis test compared to a one-tailed. Now the effect size, when I entered it in over here, I took the mean of group 1 minus the mean of group 2, used the standard deviations, and it pools those. And we came up with an effect size of 0.92. So that actually was a rather large effect size. When we padded in attrition, now the sample size calculator we probably used was slightly different than this one, but it was in the ballpark range. So we came up with 25 per group. So if I look at this, they ended up using really a two-tailed t-test if you look at that, just based on the sample size. Adding in 20%, we came to 30 per group. So that magnitude of that effect size, was it small, medium, or large? Well, in fact, if we look at Cohen's d, looking at mean differences, it was a large effect size. Now you're probably asking yourself, why are they basing their effect size on a mean difference when they're looking at differences in degree of motor blockade with ordinal level data? Well, it was the best evidence they had at the time. No studies had used a Bromage. They'd used Bromage scales, but they looked at time to full motor recovery. And the students, based on logistical restraints, basically they didn't have the time to follow all these patients to complete motor blockade recovery. And so they made that argument. So they made a reasonable argument in the manuscript. The peer reviewers bought that when we had to make some revisions to it, but they accepted our explanation. And also, it was a pilot study. And then it also went on to make some assumptions that we would find a similar effect despite using a much more dilute local anesthetic solution. And so that's why we thought that maybe we would find a 50% difference, which in this particular case, when we used the effect sizes that we find from the other studies, that actually was a large effect size. So we made our best guess. Now the question is, what did we find? Well, if we look at these two figures, so this is figure 1 and figure 2 from the manuscript. Excuse me. So what we found was the saline group right off the bat. There was a significant difference in sensory dermatome level at baseline before we gave the saline bolus. With the experimental group having a T8 level versus a T10. So they had a higher sensory dermatome level. But then you can see there's no differences at any of the other time points. Now here, if we look at the degree of motor blockade with the Bromage scale, with complete being purple and green being almost complete. So those are significant degrees of motor blockade. Now if we just look at the data, this is baseline, treatment group, and control group. That slight differences there, but what we're seeing is a little bit larger effect there. No significant differences at baseline, 15 or 30 minutes. But at 45 minutes, we see a pretty large difference, at least in the almost complete group. And then there's no significant difference there. So there's a trend overall that favors the saline bolus compared to the control group. But with this sample size, we only found a significant difference at 45 minutes. I mean, this wasn't a huge sample size. So the saline group had a significantly lower degree of motor block at 45 minutes only. However, there was a confounding variable. There was baseline differences in sensory dermatome levels in the treatment group compared to the control group. So what did we conclude? That that we did suggest because there was baseline, we had a confounding variable in sensory dermatome levels at baseline. That we really felt like these really should be considered preliminary pilot study findings. And that the lack of significance at all other time points other than 45 minutes was likely because the study was underpowered. Remember, we chose a large effect size, and in fact, maybe the effect size is much smaller than we anticipated. Maybe that's because of the differences in the concentration of local anesthetics used. Here, if we go back, why were there baseline differences in sensory dermatome levels? So if you look at their table 1 that we have here, you can see that overall there was no significant difference between the groups on baseline demographics or clinical characteristics. However, there is some data to suggest if we look at time since last bolus and anesthesia-administered top-ups, the experimental group had a shorter amount of time compared to the control group of time since last bolus, and they required a few more anesthesia-administered top-up boluses. So you take that in the context of a higher, so that would explain why they had a higher sensory dermatome level. So what were the study limitations? Well, it was underpowered. We didn't achieve our sample size of 30. We only got to sample sizes of around 27 and 26, so a little bit lower. The effect size is probably much smaller than was estimated. There's a lack of control of the PCEA infusion rates, type, and concentration of local anesthetic top-up boluses. We didn't control for a lot of these things, and so those can be confounding variables. There was no blinding of the investigators, data collectors, or the patients of what group assignment they were in. And we didn't measure time to complete motor block recovery like the other studies did, and that may be a more clinically relevant. So, what type of error was committed in the study? Well, the most common one you see in anesthesia literature, a type 2 error. That we found no difference. Well, we don't know because we have to do future studies, but the study was underpowered, so there's a high chance of a type